Find the area between the curve f of x is equal to 3 cos x and the x-axis from x is equal to 0 to x is equal to 2 pi. All right, so we have our picture given to us in this case. And this is what it refers to, right? When they say between the function and the x-axis, you can see some of the area is above in some cases and it's below in other cases. So really the strategy here, we're gonna have to just figure out the area of each of these and then add them all together. Remember when we find the area of the function, that this will end up coming out negative because it's below the x-axis, but we really just want all the area added together, so we'll take the absolute value of that when we do it. Okay, so if our function is, f of x is equal to 3 cos x, then it must be the case that the derivative of the area function is equal to 3 cos x. Okay, so then this is my differential equation. So then from here we're going to say, okay, then that must be that the area function must be equal to the antiderivative, which is equal to, and then the antiderivative would be 3 sine x plus c. So now the next step, typically what we've done in the other questions, is we just take our upper bound and our lower bound and then subtract those two. But that's not going to work this time. What we're going to have to do is like I said, find each of these pieces and then add them all together. Okay. All right, so let's say area 1. So we're going to do these one at a time. So area 1. So area 1 will be, and then we'll say it's the antiderivative at pi over 2. So f of pi over 2 minus f of 0. Okay, so just the area from here to here. All right, so the area 1 would be, and then this would be 3 sine pi over 2. And then it is plus c, but like from the last questions, you're probably used to this now, that the c's are going to cancel. So if you're okay with it, I'm going to drop the c. And then, so then it's minus 3 sine of 0. Okay, so then let's see what we got there. So area 1 would be, so this would be 3 times, then sine pi over 2 is just 1. And then 3 times, then sine of 0 is 0. So those cancel. So our first area, so area 1 is equal to 3. Let's put a box around that because we're going to need that in a minute. Okay, moving on to the next one. So then area 2 would be, so now I'm going to go from here to here. Let's find this middle section. So that would be f, the antiderivative, at 3 pi over 2 minus f of pi over 2. All right, so from here, so this is really, so this would be 3 times sine of 3 pi over 2 minus 3 times sine pi over 2. So this is 3 times, and this becomes negative 1, minus 3 times 1. So this comes out to negative 6. All right, so what that's referring to is just below the x-axis. That's like negative 6. I don't really care about the negative. I want like the absolute value of that. So that's what we should have done here. It should have been like the absolute value of these. So this all came out to 6. Okay, so that's what we have so far. That's 6. This one was 3. And you can probably tell from symmetry that this is going to be 3, but let's actually check for good measure. All right, so A3 is equal to, and then we've got f of 2 pi minus f of 3 pi over 2, which would become, so that's 3 times sine 2 pi minus 3 times sine of 3 pi over 2. So this is 3 times, so sine of 2 pi is 0, minus 3 times -1. Okay, so this comes out as 3, just like we were expecting. Okay, so what was our total area? So our area total would just be 3 plus 6 plus 3 is equal to 12.